Hello everyone, you are welcome to solve this nice algebra problem, which is a to power b minus b. This is equal to 77. And given that a and b, these are members of natural numbers, and that a is greater than 0, and that b is also greater than 0. So the question is, what is the value of a and what is the value of b? Solution from here. Now, we have that a to power b subtract b, this is equal to 77. We can express a to power b as a to power b raised to power 1 subtract b to power 1, this is equal to 77. Now we can express 1 as 2 over 2. So let's substitute this. So this is the same thing as a to power b raised to power 2 over 2 subtract b raised to power, this is raised to power 2 over 2, this is equal to 77. Now we can express this as a to power b. Now 2 over 2 is the same thing as a half times 2 subtract b raised to power 2 over 2 can be expressed as a half times 2, this is equal to 77. Now given that a to power n raised to power m, this can be expressed as a to power n times m. So applying this property, then we have a to power b over 2 squared subtract b to power, that is a half raised to power 2, this is equal to 77. Now this equation is actually in the form of x squared minus y squared, which is the difference of two squares, which you can express as x plus y, x minus y. So applying this property, then here we'll have a to power b over 2 plus, now b to power half, this is the same thing as square root of b, and then we'll have here a to power b over 2 subtract square root of b, this is equal to 77. Now from here you find that a to power b over 2 plus square root of b, this is actually greater than a to power b over 2 subtract square root of b. So this condition owns. So therefore, from here, let's get the prime factors of 77. So we have a to power b over 2 plus square root of b. And then we have a raised to power b over 2 subtract square root of b. This is equal to, now the prime factors of 77, one of them is 77 times 1. Then we have 1 times 77. Then we have 11 times 7. Then we have 7 times 11. Now, given the condition that a to power b over 2 plus square root of b is greater than this, then you find that the first condition owns and this satisfies that. But 1 times 77, this does not satisfy. 11 times 7, this condition is satisfied. But 7 times 11, this condition is not satisfied. So we have case 1 here, and we have case 2. Let's start with case 1 here. Let's start with case 1. Now case 1, we have a to power b over 2 plus square root of b. Then we have a to power b over 2 subtract square root of b. This is equal to 77 times 1. So now in this case, we have that a to power b over 2 plus square root of b. this is equal to 77, and that a to power b over 2 minus square root of b, this is equal to 1. So now this is a system of two linear equations. So let's add these two systems of linear equations. So now a to power b over 2 plus a to power b over 2, this is actually 2a raised to power b over 2. Now square root of b plus negative square root of b, this simplifies, and the 77 plus 1, this is equal to 78. Now let's divide both sides by 2, so that a to power b over 2, this is equal to 39. So a to power b over 2 is equal to 39. So let's substitute this into equation 1 here. So equation 1, we have a to power b over 2 plus square root of b. This is equal to 77. So substituting a to power b over 2, which is 39, we'll have 39 plus square root of b. This is equal to 77. So square root of b will be equal to, let's take 39 on the right hand side. So here we'll have 77, subtract 39. And this is equal to 38. So square root of b is equal to that. So we have that the square root of b is equal to 38. So that b, we square both sides here. So that now b will be equal to 38 squared. This is 1444. So this is the value of b. Now if you recall, we hint that a to power b over 2, this is equal to 39. So let's substitute the value of b here. So this is a natural number. This is a natural number. Now we have that for a, we have a is a to power b over 2 is equal to 39. Let's substitute b here. So we'll have a to power 1444 divided by 2. This is equal to 39. So let's simplify here. By 2, 1, by 2, 7, 22. So we have that a to power 722. This is equal to 39. So for the value of a here, we get the 722 roots. This is a to power 722. Now this is equal to the 722 root of 39. And therefore from this part, you find that a will be equal to the 722 root of 39. And this is not a natural number. This is not a natural number. So this solution is rejected. So this solution is rejected. So let's proceed to case 2. Let's proceed to case 2. Now in case 2, we have a to power b over 2 plus square root of b multiplied by a to power b over 2 subtract square root of b. This is equal to 11 times 7. So this implies that here we have a to power b over 2 plus square root of b. This is equal to 11. And we have that a to power b over 2 subtract square root of b. This is equal to 7. Now these are two systems of linear equations. So let's add these two systems of linear equations. We'll have a to power b over 2 plus a to power b over 2. This is 2a to power b over 2. Then square root of b plus minus square root of b, this simplifies. Then 11 plus 7, this is 18. So let's divide here both sides by 2. So that a power b over 2, this is equal to 9. Now, let's substitute this into equation 1. So equation 1, we have a to power b over 2, which is 9, plus square root of b. This is equal to 11. So this implies that square root of b is equal to 11 subtract 9. So and therefore, square root of b, this is equal to 2. And this means that b, we square both sides. So that b is equal to 4. So b is 4. And therefore, we can be able to calculate the value of a. So remember, we have that a to power b over 2, this is equal to 9. Okay? So given that b is 4, we'll have a to power 4 over 2, this is equal to 9. So this implies that if we simplify here, a squared is equal to 9. So this means that a is equal to square root of 9, which is equal to 3. So you can see that a is a natural number and b is also a natural number. So that means that a comma b, that is 3 and 4, this is the only solution that satisfies the equation. This is the only solution that satisfies the equation. So we have that this solution AB, which is 3, 4, this is the only solution that satisfies the equation. Okay, so let's verify that this solution actually satisfies the equation. Now, if you recall here, we entered a to power b, subtract b, this is equal to 77. So a is equal to 3. So we have 3 to power b, which is 4. Subtract b, which is 4. And this is supposed to give us a value of 77. So 3 to power 4, this is equal to 81. So essentially, we have 81 minus 4. This is supposed to give us a value of 77. So 81 minus 4, this is 77, which is equal to 77. So the left hand side is equal to the right hand side. And this satisfies the equation. So the solution AB satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video.